All right, welcome, number detectives. Today, we are on a very special mission. We are going to uncover the secret codes hidden deep inside numbers. So, get your thinking caps on, because we're about to crack the case of the H.C.F. and L.C.M. Let's get started.
I mean, really think about it for a second. Are numbers just these boring squiggles on a page, or do they actually talk to each other? Well, I'm here to tell you they absolutely do. And today, you're going to learn exactly how to understand what they're saying. You know, every good detective starts with the very first clue. And for us, that clue is something called a multiple. So let's dive in and find out what it's all about. Okay, whoa, that sounds a little textbooky, doesn't it? Let's forget that for a second. It's actually super simple. A multiple is just what you get when you skip count by a certain number. That's it. It's basically just that number's times table. Check this out. This shows that skip counting idea perfectly. If we're looking for the multiples of 3, it's just 3 times 1, which is 3, then 3 times 2, which is 6, 3 times 3, which is 9, and yeah, it just keeps on going forever. See? Simple, right? All right, detective, let's dial up the challenge just a little bit. What happens when we have two different numbers we're investigating? Well, sometimes they actually share the same multiples, and we call these common multiples. They're the numbers that pop up on both of their skip counting lists. Let's look at a real example here. We've got the lists for 3 and for 8. Now, if you look closely, hey, wait a second. The number 24 is on the list for 3, and it's on the list for 8. And look, so is 48. These are their common multiples, kind of like the secret meeting spots for these two numbers. Okay, so now that we've found their secret meeting spots, it's time for the L.C.M. challenge. What we're really looking for is the very first place they meet. And trust me, this is a super important clue.
Finding the lowest common multiple, or LCM, is as easy as 1, 2, 3. Seriously. First, you list out the multiples. Second, you find the ones they have in common. You can circle them. And third, you just pick the smallest, the lowest number that you circled. That's all there is to it.
Let's try it out with 8 and 10. So we list out their multiples and, let's see. We find that they both have 40, and they also both have 80. So which one is the lowest? Well, it's 40, of course. So the LCM of 8 and 10 is 40. Case closed. Psst, come here a sec. You want to know a secret? Every pro detective has a couple of tricks up their sleeve, so here's a little shortcut to make you an even faster number detective. So instead of writing out two really long lists, just take the bigger number. In this case, that's 10, and start listing its multiples. Then you stop at the very first one that the smaller number, 8, can also divide into. So we go 10, nope, 20, nope, 30, still no. 40, yes. 8 goes into 40, so 40 is our LCM. See? Way faster. All right, on to our next clue. We've seen how numbers get bigger when we look at multiples, but now we're going to break them down into their basic building blocks. We call these factors. You can think of them like the Lego bricks that make up a number.
So what is a factor? Well, it's any number that can divide into another number perfectly, with absolutely nothing left over. No remainders allowed in this detective agency.
Take a look at the number 20. Its factors are 1, 2, 4, 5, 10, and 20. But what's really cool is how they come in pairs that multiply together to make 20. You've got 1 times 20, you've got 2 times 10, and you've got 4 times 5. They're all the little pieces that build the number 20.
And yep, you guessed it. Just like with multiples, different numbers can share the same factors. So here we're comparing 12 and 20. What Lego bricks do they have in common? Well, they both have a 1, they both have a 2, and they both have a 4. Those are their common factors.
And that, my friends, leads us to our final and maybe our greatest clue of all. We've found the common factors, but now we need to find the most important one, the highest common factor, or H.C.F.
You know, this might actually be the easiest step of the whole investigation. We already listed the common factors for 12 and 20. They were 1, 2, and 4. Now, all we have to do is pick the biggest one. The highest number on that list is 4, so the H.C.F. is 4. You've officially cracked the code. Okay, let's just pause for a quick recap because this is the number one thing people get mixed up. Just remember this. Multiples make numbers get bigger. You're multiplying, you're skip counting, you're going up. Factors, on the other hand, break a number down into smaller pieces. If you can just remember that one thing, you'll be a master detective for sure.
Now, before we wrap up, I've got a little bonus for you, a piece of top secret intel.
There's a special kind of number out there, a number with a code that's basically unbreakable. These are the prime numbers.
Prime numbers are kind of like the ultimate minimalists of the number world. They only have exactly two factors, the number 1 and the number itself. That's it. They can't be broken down any further than that.
A perfect example is the number 11. The only whole numbers that can divide into it are 1 and 11. That makes it a prime number. Now, any number that has more than two factors, like our old friend 20, is called a composite number.
And just like that, you've done it. You've learned the secret language of multiples and factors, L.C.M. and H.C.F. You are officially a number detective. So the only question left is, now that you have these amazing skills, what other secret codes and patterns will you find hidden in the world all around you? The investigation has only just begun.